Welcome to Maths and Science by IITian channel. In this channel, now I have started a course of 20 top questions, challenging questions in thermodynamics for NEET, JEE Mains and JEE Advanced. These are very good challenging questions made by me, suitable for NEET, JEE Mains and JEE Advanced, and I will be releasing 20 top questions from my side. And in this lecture, I will be taking the part 1. This is a practice question. I will be discussing many concepts in each and every question. It will be of different concepts and we will be dealing them separately. And in this lecture, I will be taking up in the part 1 one question for you to understand the concepts, and 20 top questions in thermodynamics I will be taking up. Let's go for the question. It's a very challenging question. It's not that easy, at the same time it's not that tough if you understand the concepts. Let us try to understand what is the question given here. A 1:1 molar mixture of ideal gases A and B with molar capacities. The molar capacity equation is given how they are related to each other. CV I means gas 1 and gas 2. Gas 1 is gas A and gas 2 is gas B. CVI having a function of temperature is equal to R by gamma I minus 1 into 1 plus alpha IT. Gamma I and gamma 1, gamma 2 are given. The values of gamma 1 and gamma 2 are 1.6 and 1.3. And alpha 1 and alpha 2 are also given. Alpha 1 is equal to 3 into 10 to the power of minus 4 and alpha 2 is equal to 5 into 10 to the power of minus 4. And temperatures are also given. And this particular mixture undergoes a reversible adiabatic process. From temperature 450 Kelvin to 600 Kelvin. Then we have to find out the ratio of final volume by initial volume. V2 by V1 is equal to how much? Even the question looks simple, it's not that simple. We have to find out the behavior of the process, and from the behavior we have to understand the entropy integration. From the entropy integration we have to put in the values, and then for the mixture how it behaves. It's not a single gas, it is a mixture of gases. Then we have to find out V2 by V1 value. It's a 3-4 concepts based question, a very good question, a challenging question. Please see from starting till the end so that you will grasp maximum concepts as possible. If this type of questions are asked in JEE Advanced or JEE Mains, you will be able to answer them. Let's move further and try to understand what are the concepts hidden in this particular question. And let us try to solve the question. What is the question? Question is find the ratio of final volume by initial volume. V2 by V1 is equal to how much when the process is reversible adiabatic. In this, some hidden concept is there, I will explain now. In each and every sentence of this problem, there are hidden concepts. And the values of alpha 1 is equal to 3 into 10 to the power of minus 4. Alpha 2 is equal to 5 into 10 to the power of minus 4. Gamma 1 is equal to 1.6. Gamma 2 is equal to 1.3. The symbols alpha, gamma, V, where they are used, how they are used, by this time you should have been familiar. Be familiar from the basics of thermodynamics. These are little bit of advanced thermodynamics problem solving lectures. Let's not go to the very basic level in understanding these questions. Now, the heat capacities, molar capacities, the molar heat capacities are related as CVI is equal to, this is what is given, with temperature T as a function of temperature T is equal to R by gamma 1 gamma I minus 1 into 1 plus alpha I into T. The values of gamma 1, gamma 2, alpha 1, alpha 2 are given. Then CV1, CV2 you can easily find out. Now, let us try to solve this question. Here, the process is given as reversible adiabatic. Reversible adiabatic. That implies it is isentropic. Isentropic means entropy is constant. Please understand this definition. This is the concept, important concept. Because you know PV diagram. Something like adiabatic process, something like this. You have a PV diagram. Now, let's go for the TS diagram. What is TS diagram? Here S, here T. T is temperature in Kelvin. It is a very famous diagram. At par with PV diagram, TS diagram is also very famous and very useful. And in many thermodynamic processes, TS diagram is used over PV diagram. S is entropy. It is temperature in Kelvin. Isentropic means entropy is not changing. That means the vertical line like this. With temperature, entropy is not changing. From process 1 to process 2, there is a temperature change from T1 to T2. But in isentropic process, the entropy is not changing. Delta, it's a vertical line. Delta S is equal to 0. Change in entropy is 0 with temperature. This is what is isentropic process. That means reversible adiabatic process is an isentropic process. Reversible, whenever there is a word called reversible adiabatic process, that you can treat it as isentropic process. Entropy is constant and it will be a vertical line on the TS diagram. Now, that means the total change of entropy is equal to 0. There are the mixture of gas mixture is equal to 1:1. You see in the question, it's 1:1 molar mixture. Usually, the controlling equation for entropy, relating entropy and volume and also molar capacities, heat capacities, molar heat capacities, there is a controlling equation. That controlling equation is, please remember, because you might have studied it, if you have forgotten, please write this. The controlling equation is T1 to T2 C V I T, because in terms of temperature it is given. I am writing only equations relevant to this particular question. dt plus R into ln V2 by V1, where R is the universal gas constant. Please remember this equation. Now, delta S total, as per the sentence, that is reversible adiabatic process, isentropic process, that is equal to 0. Delta S process is sigma delta Si. I is equal to 1 to 2, because there are two gases. That is delta S1 plus delta S2. If you substitute these values in the above equation, delta S1 plus delta S2 is equal to 0, because the total process is isentropic. Hence, when you substitute this in this, integral T1 to T2 C V1 T divided by T dt plus R ln V2 by V1 plus integral T1 to T2 CV2 T divided by T dt plus or ln V2 by V1 is equal to 0. Do you agree? This equation implies integral T1 to T2. Here it is CV1, here it is CV2. CV1 T divided by T plus CV2 T I have added these two. I think there should not be any confusion for you how I am getting these equations. dt plus 2 into r into ln V2 by V1, that is equal to 0. From this, we can get an idea that we will get the value of V2 by V1. This is what is required for us. This is how much? This is the controlling equation. In this controlling equation, we know all the values. And so that we can get the value of V2 by V1. From the above equation, what we will get is ln V2 by V1 is equal to minus 1 by 2r integral T1 to T2 CV1 T plus CV2 T divided by T dt. Now, before putting the values, before substituting the values, we have another what is the value of now? What is the value of CV1? That means ln V2 by V1 is equal to minus 1 by 2r integral T1 to T2. What is CV1T? CV1T is CVIT is equal to r by gamma I minus 1 plus alpha IT. In that, what is the value of CV1IT? I will write r divided by gamma 1 minus 1 into 1 plus alpha 1 t plus r divided by gamma 2 minus 1 into 1 plus alpha 2 t. This is what is given. Whole divided by t dt. Are you able to follow me? Now, ln v2 by v1 is equal to minus 1 by 2r. Here r, here also it is there, r is a constant, universal gas constant, r gets cancelled, then it will be minus 1 by 2 integral t1 to t2. Gamma 1 is what? 1.6. Let us try to substitute the values. 1.6 minus 1 into 1 plus alpha 1t. Alpha 1 is how much? 3 into 10 to the power of minus 4. 1 plus 3 into 10 to the power of minus 4 into t plus 1 by gamma 2 is 1.3. 1.3 minus 1 into 1 plus alpha t. 1 plus 5 into 10 to the power of minus 4 t. This whole divided by t dt. Sorry, t is capital. Here also t is capital. Now, we get the equation, simplify it, v2 by v1 minus 0.5 into integral t1 to t2, 1 by 0.6, 1 by 0.6 into 1 plus 3 into 10 to the power of minus 4 means 0.0003. 0.0003 t plus 1 by 0.3 into 1 plus 0.0005 t whole divided by t dt. That implies ln v2 by v1 is equal to minus 0.5 into integral t1 to t2. What is 1 by 0.6 plus 1 by 0.3? 1 by 0.6 plus 1 by 0.3 is equal to, this is 1.6, it is around 1 by 0.6 is equal to 1.6. This is around 3.3. 1 by 0.3 is this is 5 plus 0.003 t by t into 0.0003 by 0.6 plus 0.0005 by 0.3. This whole divided by t dt. These are all simple arithmetic which you can do it with ease. Ln v2 by v1 is equal to minus 0.5 into, because you are given the online calculator, you can do with calculator with ease. There should not be any problem. 0.0003 by 0.6 is 0.0055 plus 0.0005t plus 0.0005 divided by 0.3 is equal to 0.0016 t. This whole divided by t dt. From the above equation, ln V2 by V1 is equal to minus 0.5. This is total common. Integral T1 to T2 5 by T dt plus 0.005 plus 0.0016 t, t by t gets cancelled, 0.0021. This dt we will not write here, 5 by t plus 0.00t1 total dt. For the total integral, this is the value. Minus 0.5 into integral t1 to t2 5 by t dt plus integral t1 to t2 0.0021 dt. This is the value, simplified value we will get. Then ln V2 by V1 is equal to minus 0.5 into 1 by t dt is ln t. That means 5 into ln t, integral of 1 by t is ln t. T1 to T2 plus 0.0021 t, T1 to T2. This is the value of the integral from the basics of the integration. Ln V2 by V1 is equal to minus 0.5, 5 into, what is T1 value? T1 is equal to, it is given that T1 is equal to 450K and T2 is equal to 600K. That is ln 600 by 450. This is the value. This value. Plus 0.0021 into 600 minus 450. This is the value. This small algebra and arithmetic you should be able to do it independently on your own. Ln 600 by 450, what is the value? You may be given online calculator from which you can easily find out ln 600 by 450, which is 0.287. 5 into 0.287 plus 0.0021 into 150. That is equal to minus 0.5 into 5 into 0.287 is how much? 1.435 plus 0.0021 into 150 is equal to 0.315. That implies, we just see how we are proceeding. ln V2 by V1 is equal to minus 0.5 into, what is 1.435 plus 0.315, that is 1.750. I am taking only up to 3 digits. 1.750 into 0.5 is equal to minus 0.875. ln V2 by V1 is equal to minus 0.875. That implies V2 by V1 is equal to e to the power of minus 0.875. Then V2 by V1 is equal to e to the power of minus 0.875 is equal to 0.416. I am taking only 3 digits. This is the answer. The ratio of final volume by initial volume is equal to 0.416. That means it shows a compression, adiabatic compression. In compression, what happens? In a compressor, when there is an expansion, there will be a reduction in temperature. In compression, there will be a increase in temperature. T increases in compression, V decreases. T decreases in expansion and V increases in expansion. These two concepts, please remember, any objective type question can also come on the basis of these concepts. That means in this question we have cleared many concepts. One is, we have utilized the process isentropic, which is reversible adiabatic. From that we have derived that delta S total is equal to 0. From that we got the equations. Then the most important equation which we have used is delta Si is equal to integral T1 to T2 CV I T divided by T dt plus R into ln V2 by V1. Very important equation. With these two concepts, we have developed the problem and we have developed the isentropic integration, and we could solve this problem. Isentropic integration formula, and we have integrated and we got the value, and we have also assured that whatever answer we get, that satisfies the physical concepts which till now we have read or understood from literature, that whenever temperature increases, that denotes a compression where volume is reduced. Whenever temperature decreases, that usually denotes an expansion of the, whenever expansion takes place, temperature decreases and volume increases. Whenever compression takes place, there will be an increase in the temperature and volume decreases. V2 by V1 we got 0.416, that denotes that the final volume is lesser than the initial volume. Hence, the process is adiabatic. Process is adiabatic. Rather, we write like this: reversible adiabatic. Reversible adiabatic compression. With this, I want to conclude this lecture because this particular problem was vast and very typical and very relevant to your IIT JEE Advanced and IIT JEE Mains or CSIR physics and also NEET physics. I thought I will explain in detail, and I want to conclude this lecture now as a part 1, that is one problem we have solved, and we will take up another very good advanced level problem in the second part, part 2. And up to, if the possible, if the questions are small, if I can prepare small questions, then we can go for one or two, more than one questions in one lecture, and total 20 questions, advanced level questions, most important questions, or rather I can say, which touch the core of the subject of thermodynamics and the concepts of the, which clear the concepts of the thermodynamics for you. These 20 questions I have planned, and this I wanted to release as a course for all of you. Best of luck. Thank you for listening to me. If you feel there is a value addition because of this lecture to you, kindly hype this lecture, share this lecture, and share my channel details also to your friends and known persons, and subscribe to my channel. Best of luck to everybody. Thank you for listening to me. This is a series of 20 problems, critical, important and concept oriented problems I will be giving in this course of 20 lectures. Please see them, understand the concepts, different concepts being dealt in each question. I will try to develop maximum concepts possible, and I will be releasing the same type of course material for work, energy and power also. And in addition to them, regular lectures with initial fundamentals also I will be doing. For all the physics topics, I try to do this type of advanced questions, advanced problems in a typical course, in a playlist. It will be a separate playlist and a separate playlist for fundamentals. Thank you for listening to me. Best of luck to everybody.